3, 2, 1. Hi everyone, welcome back to our channel here at The Construct, Becoming a ROS Developer. My name is Rodrigo, and today we have one of our students, Kinran, who took our ROS 2 basics in 5 days. And today, he's going to be showing us the final project he had to do for that course. So he takes a course, and then he implements what he learned in a project in which he applies his knowledge into a real robot here at The Construct. So without further ado, I'm going to introduce you to Kinran. Hi, how are you, Kinran?
Hey, good, I'm fine. How about you?
Great. So yes, whenever you are ready, you can go ahead and start sharing your screen and start explaining us and telling us a little bit about your project.
Sure. Let me first share my screen. So, can you see my screen now?
Yes, we can see it.
Right. So, basically, here's a real robot. And what I'm first gonna do is to try to get the program running. So, let's just try to connect to the ROS bridge so we can communicate with the robot. And I
Okay.
will then launch my program.
It looks like the camera on the right is frozen. So if you need more space on your terminal, you can just like drag the
Right.
window. Oh, no, it's
Right.
working now. Never mind.
Well, I just very accidentally paused it, but it should work now.
Right on. So then this terminal on the right, you're launching the ROS bridge.
Yes.
And for those that don't know, this is to connect ROS 1 and ROS 2. Because the robot that you're seeing on the screen is running on ROS 1, and we're going to be sending commands in ROS 2.
Yeah, so now my ROS bridge is up and running. I can just hide this window and then another terminal I can try to source what I have. So let's source my instance just to be sure I have everything I need. Let's source my so I guess I will just move the robot to a convenient position first. I haven't tried this position, but hopefully it will work. So let's launch my program, which will follow the wall. Let's name dot launch. See if it runs. So hopefully you can see that the robot now is
It started
rotating
moving.
itself. So it's finding the wall.
Okay.
Okay, so it finds the wall. It goes towards it. I think it goes might be a bit too far, but might get stuck in it. I need to try with another position because I think that was too close to the
Okay.
wall and it just go all the way to it. Maybe it's still turning, but I cannot see with the camera.
Right. It's like a weird
Maybe it's
position.
get stuck. So I will just cancel this and maybe we'll try with another position.
Okay.
Because I think that was a bit too close to the wall and just get bumped into the wall. The other direction.
What's the place where you've
So
seen
I
that?
think I tried more on the lower left corner and also the upper left corner. I didn't try the right side. So I
Okay.
think I try somewhere like here, so it should work. I don't know, I will make it face away from the wall, so it will try to find the wall itself instead of me facing it to the wall already.
Mm.
So let's launch the program again and see if it finds the wall. So again, now it's trying to rotate towards the wall. Mm, yeah, I think it's found the wall now. So it's facing the wall and then it will move towards the wall and then it will stop. So, get stuck again. Not sure why. It worked yesterday. Now we'll pull it away from the wall a bit further.
Mm. So are you setting it to go towards the smallest value? Because I see it going towards the corner. Is that by design or?
It's going to the smallest value the laser scan is reading.
Right. So
But I think the
if we do it
velocity is
here,
too fast and then it cannot stop itself when it sees the wall. It just bumps into it and
ah,
then
all right.
um, it tries to turn, but it's already touching the wall. I think the velocity might be a bit too fast.
Or maybe the stop command happens too close to the wall.
Hopefully it works this time. So it's finding the wall. It's turning towards it. Oh, yeah, why is it happening like that? So it's
Yeah, it looks like. I mean, let it go. Don't kill it because it looks like it's twisting. Let's see if this. I mean, I know it's crashing against the wall, but let's see.
yeah, I think it's turning this time. It's not completely stuck. So now it's facing. Yeah, it's moving itself. Yeah.
Yeah. All right.
So now it's trying to follow the wall. It will turn itself when it's sensing a wall is too close to it.
I
So now
see.
it's more or less on track, I think. Yeah, yeah. Not so sure why it didn't work in the beginning because I tried.
Hi, Kinran. Hello, hello, hello.
Yeah,
Oh, hi. It looks like we had a um, connection issue because we lost you for a while. Can you hear me, Kinran? Kinran, can you hear me? Hello, hello. Hello, Kinran. Can you hear me, Kinran? Looks like he cannot. Let's see if. Hello, Kinran. Kinran, can you hear me? Seems like we have lost connection.
Hey,
Kinran, can you hear me?
yes,
Yes, okay, I can hear you. Okay, you can
yeah,
hear me now. Great. Looks like we're having connection issues.
yeah. But my robot is it running?
I need to know if you can hear me or if we're still having connection issues. All right, you can't hear me. All right, we'll give it a couple minutes, see if his connection improves, and then we can either keep going or plan this again. Yeah, he's completely frozen. I don't know if it's me. I don't think so. No, my internet is fine. Yeah, yeah, yeah. All right. So yeah, okay, we have lost them. So let me get here. Ah, there we go. There we go. Okay. So yeah, sorry guys, we seem to have connection issues with Kinran. So hopefully we will wait a couple of minutes, and if not, we're gonna have to reschedule this one for the next time. But yes, what he was showing us was our project that we have at the construct for the ROS2 basics, and actually ROS basics as well, in which you have to. Oh, looks like he's coming back on. Let's see. Hi, Kinran, you're back.
Hey, sorry for that. I'm not sure why it's not
Don't
so
worry.
stable connection.
Don't worry. It seems like we had some connection issues. So we can do this. We can go ahead and we saw that it was doing its thing, but it was freezing. Your voice kept coming in and out, and you couldn't hear me. But let's
Yeah,
hope. Let's hope that this is now all right. You don't have to do the real robot part. We'll check that afterwards. But if you want, share your screen because we're still live, and just start explaining each section of the project, please, so we can
yeah.
get an
So
idea.
just also wanted to say I think it finished one lap. So
Oh, nice.
meanwhile we were losing the connection. I think it finished one lap and it's still going on.
Great. Explain
But we
to us
also
what it
got
was
the
doing. Explain to us the whole process.
right. I can find the odometry data. Maybe not. But basically, it's still running. Should I stop the robot now, or
No,
should I
no. I mean,
just?
let it do its thing. We can
Okay,
see that
yeah,
it's responding to your program, so that's good.
yeah. We'll see how many laps it can run. I think I try ultimately it might run into a wall. Like
All
now,
right,
it
all
cannot do
right.
like more than 3 laps or so. I think. It depends on the starting position, but I think the
Yeah,
program can be improved. But at least I think it can do at least one lap.
perfect.
So
So yeah,
perhaps I
you can
should
kill this so it's not like pushing against the wall.
pushing it against the wall. Yeah. So I guess I will explain how it works, although it's
Please.
not too optimal. Can you see my PowerPoint presentation now?
Mm-hmm.
So today I want to talk about how did I program this robot to follow the wall. So I think there are three main components in this program. So the first component is to find the wall. So basically it just means turning to the wall and then going towards it, and then finding the starting position before following the walls.
Right.
And
I
then the
like that.
second component is following the wall. So basically just go around and then return to the starting position.
Mm-hmm.
And on the way, we also want to record the odometry data, which is basically the coordinates that we have visited and the distance traveled. And to do that, here is the RQT graph showing you what components are there. You have some topics, you have some servers and clients in order to make these three functions possible.
Mm-hmm.
So we'll go into each of these components one by one. So I wanted to start with following the wall because this is the main behavior of this program. So the main components here is we basically have a robot, which is communicated via the ROS bridge. And then we have a wall following node here. So the wall following node is subscribed to the laser scanner from the ROS bridge or the robot.
Mm-hmm.
And then it's basically publishing velocity command to the robot every 0.5 second.
Mm.
So this is important. We have a timer function here. It is triggered every 0.5 seconds because we will always get the laser scan data whenever is possible. But we only publish the velocity data every 0.5 seconds. So these topics, they are not really blocking each other. So we don't need to use a multi-thread executor. In this case, we can just use a single thread executor by default. So for the algorithm, it's also quite straightforward. Basically, if you see a wall in the front, you will turn left, so you don't go into the wall. And if the wall is on the right, you want to keep an appropriate distance from it. If it's too close, then you want to move away. If it's too far from the wall, you want to go closer to it. And if it's just at the right distance, then it will just go straight. So in order to do this, we need to figure out how to read the laser scan in the front of the robot and also on the right of the robot. So to do this, we need to figure out how does the scan data look like. So we can do a simple echo to look at how does the scan topic look like. So this is the kind of structure of the scan message. So the most important message here is the angle, mean, and max, and the increment. So here the angle is in units of radian. So it's go from minus 3.14 to plus 3.14 radians, which is just minus 180 to plus 180 degrees. And the important thing here is the increment is 0.00873, which means that we have 720 steps in this minus 180 to plus 180 degree. And with a bit of trial and error and figuring out which is the right readings we want, it turns out that if we look at the laser scan array, what we want is actually number 359 or basically 360. So if you go to the array and you read the array number 360 is basically the front laser scan. And if you read the 180th element in the array, you'll basically get the right laser scan reading. So we can make use of this and code this algorithm. With this in mind, actually it's pretty straightforward to just convert this idea into code. It's just directly translating this idea. Now we know that how to read the front and the right laser. So here are some parameters we can tune to make this wall following behavior more optimum. So I think I just picked the parameters which are not so optimal. So you can see it in the actual execution, it might run into a wall after like 3 laps or 4 laps because sometimes it's not turning enough or sometimes turning too much. So it runs into a wall. But these are parameters we can tune, which is the linear velocity and the angular velocity of the robot every time when it's trying to go away from the wall. But other than that, the algorithm is fairly straightforward. And the next behavior, which is important, is the finding wall behavior, which is basically the initial, finding the initial starting point before we follow the wall. And this can be done again, visualized by this RQT graph here. This time, we actually have a server and a client, and this server node is actually also subscribed to the scan topic. So now we have an issue because the server has to be on all the time, and also we have to subscribe to the scan topic. So this time we need a multi-thread executor. So they are not blocking each other. So when I started this project, I think this multi-thread executor was not introduced in the course yet, so it took me a few hours to figure this out.
Yes,
but,
we have just
I'm,
included it. Yes,
I'm very glad that now it's included. So I hope students taking this course in the future will not struggle as much as I do, because it took me a few hours to realize they're actually blocking each other, and the laser scan just do not update at all. So what we need to do is just to set them to 2 different callback groups. You can use mutually exclusive callback groups or reentrant. Basically, just assign them the 2 callback groups, and then you use a multi-thread executor to execute both of them. Otherwise, if you just use a single thread executor, they will block each other.
Right.
I think this is the biggest challenge. Other than that, again, the algorithm or the task itself is fairly straightforward. We just have to find a wall by the shortest distance and then rotate until it's facing the wall, and then just go towards it and then rotate again so the wall is on the right-hand side. So I just added a little feature here to say, should I rotate clockwise or should I rotate anti-clockwise, depending which direction is closer to the wall. But other than that, it's pretty much just converting the steps into code, and we have all the information we need. So the last step, which is recording the odometry, this is done by, again, a server, but this time we have an action server. But again, because we have a topic here, we're subscribing to the odometry topic, and then we also have to keep the server open all the time. So again, if you don't use a multi-thread executor, they will block each other. So we have to use that again. And the thing I struggle the most here, there are 2 things. The first thing is the action file. So we have to create a custom action type, which is called odometry record. And the first thing I struggle is I actually have to get I think this is the response, is it? probably the response, yeah, the final
That's
response of the list
it's. I think it's feedback,
feedback.
response, and no, the feedback's the last one. The first one's
Yeah,
request. So
yeah. I think the second one is the response end. So
yeah.
the last one is the feedback. So the second one, basically the response, you have to return a list of odoms. And I struggle a bit because I think in the course notebook, it says we should have this MSG here, but I think in the end, what get me working is actually I don't need the MSG when I want to get the pawn data structure from the
Huh.
geometry message. So that was one thing that I got struggled a bit, but that was relatively minor. Another thing I got struggled for, I think a good few hours is I didn't know that in the CMake list.txt, I have to include the extra line here. So I think in the course, it stated quite clearly that we have to put the dependency on top here, which I did. I also have included the dependency of geometry message. But then I think because in the course in the examples, we didn't use anything beyond standard message when we create the action type or any custom interface. So we don't have to include this line, but now we're including some messages beyond standard message. We have to add this extra line there because I tried so many times it compiled properly. When I try to call the custom action type, it just
The
gives me
message
error.
wasn't defined.
Yeah, so it took me forever to figure out actually I need to add this extra line of dependencies. But I think as far as I know, the courses didn't state this explicitly because normally if you just use standard message, you don't need to include this line down here. So that was the two biggest challenge I had. But again, I think the actual algorithm is fairly straightforward. Basically, you have to keep getting the odometry data from the topic, and then you update the data. And then in the feedback, you basically want to get the dxdy. You want to see every 1 second how much you have traveled, and then you add up that total distance and then report that.
Mm-hmm.
And then you also want to save the coordinates on the way so you can return the array of the positions in the very end as the response. So if you want to put everything together, you have three behaviors. You want to first find the wall, and then you record the odometry on the way, and then finally you want to follow along the walls. So here you just basically have to in the Python file, you just have to declare three nodes for them, and then we just have to execute one node one by one.
Oh,
But
nice.
we are using the client to call the servers that we have defined it, and then finally the wall follow the behavior.
Mm. And this is your
So
main program, let's say?
yes, that's the main program. We have to execute the nodes one by one in the order that we want. So with that, I think I come to an end of the presentation. So that's basically how I kind of program this robot to follow along the walls.
Awesome. Great. I have some questions, but do you mind stopping share your screen so we can sort
Sure.
of look at our faces here while we do the Q&A? Great.
Yeah.
Let me just so congratulations, Kinran. It's really nice. Nice presentation. Let me talk about first what I liked. Um, I really like your use of RQT graph. I think for those that don't know, RQT is a tool for visualizing the nodes that are running in your system and what topics are being passed between them. And I think it's a really good tool, especially for understanding what's going on and what could be missing if there's something, an issue. So I really like that you put, the wall follower
Yeah.
in the RQT. That's really nice, and
Yeah.
it
Thank you.
helps
Yeah.
it
I
get
think I
out.
think it's very important too because I didn't know about this multi-thread executor. So it took me like I need to go the extra mile to really understand this. So I think
Yes,
the RQT graph really helped me to understand this better because it
yes,
was not in the course. So now I actually understand it better after I solved all of this. So
yeah. So, and we bear some responsibility for that. So, yes, you're right. Once we realize this, now it is included in the basics. We didn't have it in the beginning because we thought it was a little bit of an intermediate thing. But then we realized, you need this for the project, so we put that in. So, that's incredible that you were able to figure that out too. I also really liked that your PowerPoint presentation. I mean, this might seem not that important, but it is, that it actually helped you present it, and it was really clear. You had videos, you had an order of it, and a lot of the times when you use a PowerPoint, it's just to fill time and to sort of overload the listener with information. You didn't do that, so great job on that. And I also really like how you did your main program, that you have the 3 classes defined, and all you do is pretty much just call them in the main. That helps things keep really clean. And once you start want to improve things, you can do it a lot faster this way once it starts getting complicated. So those things really great. Now let me ask you some questions. Well, actually, some
Sure.
comment. One comment first. Uh, I have to look at because honestly, I don't remember. I have to look at that explanation, that things you talked about, the CMake lists, and how you have to add it as a dependency because it's a custom message.
Right.
Let me look into that because you're right. Something looks strange there, that it wasn't working for you, especially because the geometry message is not a custom message, so it's a default
Yeah,
one.
I'm not so sure why too. So without that line, it never worked. But when I added that single line of
Yeah,
dependency of geometry message, and it suddenly worked. So
right.
I'm
And
not
then
so sure it's a
yeah,
necessary tool. But
so let me look into that because I was also puzzled by that. And the other way is that you talked about how uh, having the geometry message slash point did work for you, but geometry message slash point didn't, which is surprising to me because ROS 1, it doesn't have that intermediate MSG. Now for ROS 2, the messages are, with that MSG in the middle.
mm,
So I also want to take a look at that, and I don't have the answer for you because these are just like little details. So those are really important things to bring up. So we will definitely follow up on that. And now let me ask you some questions. I have 2 questions mainly. One is why was it that it was crashing against the wall? So is it a simple thing as the distance was too close, or what was going on there? Do you know?
yeah. So you mean when it's first turning to the wall, right? It's
Yeah,
just
and we saw that
goes
it
into
kind
it.
of got too close, and I just like, oh, let it go, and then it started doing it.
I think the problem is I have to set the velocity goes towards it, right? Maybe the velocity is too high, and then I think it's not the loop. I think it's only calling the velocity maybe every 0.5 seconds or so. So maybe after 0.5
Oh,
seconds, it's already crushing to it. So maybe either I have to increase the timer or
so yeah,
call
all
this
right,
function
yeah.
faster or turn the velocity down a bit to prevent it. Or maybe we move it further away from the wall. So with the same velocity, it's not immediately hitting it.
Yeah, that makes
So I
sense.
tried it. It worked yesterday, and I also tried it a few times, but somehow today it's not working. It's
I mean,
not the best. Yeah.
it's just a small thing, but I was curious. And yeah, that makes sense that your timer, you said it was running once every, I think it was point
Yeah,
five.
I don't remember, but it's several maybe
Right.
point
So
5 seconds or so. Maybe
yeah, that
this
might
is
be
already,
the overlook there
yeah.
that was happening. And this takes me back to um, the fact that you said that eventually it will run into the wall,
Mm.
right? After 3 laps, you said sometimes it'll just crash into the wall. Do you have an explanation for that?
So I think it's about tuning the angular velocity. It's a combination of the linear velocity and the angular velocity.
Hmm.
I try to, so now I'm setting the angular velocity to like 0.2, so it's not going like zigzag too much.
Mm.
But if I set it to 0.2, it's going more straight in a straight line. So I think it's a balance between these two. If I go really zigzag, then I can avoid
Oh, I
bumping into
see.
the wall. But then I don't like the zigzag pattern, which is
Yeah.
just constantly going towards the wall and going away from the wall.
Right.
If I go for a 0.2 angular velocity, then it goes more in a straight line, but sometimes it just cannot uh,
Right.
rotate fast enough to avoid the wall.
One
So it's a
thing,
balance of this.
yeah.
This.
One thing you can look into this going forward as you keep learning about robotics and ROS is that you can actually, instead of doing this if else, because this is what we told you, because it's a basics first thing to do a simple controller like that, you can look into to avoid that zigzag and tend to have it as much as straight as you can. You can implement something like a PD controller that looks at the
Hmm.
error of what the right side would be and then adjust for that. It's really simple, but take a look at that, how to do it. Because if you do it here, you could basically switch that if else chunk of code for like one line and you would see how it does it. So it's a really nice like tool to learn for the when you first see that. Oh my god. So take a look at that. And
Okay, it's a good idea.
I mean, other than that, I think everything else is covered. Let me see what else I wrote. Okay. Oh, yes. Great explanation about the multi threading. Uh, you put it very clear on why you don't need it in the main follow wall program, but when you have a server like the service server or the action server, then it would get blocked. That was really clear. A lot of times it's hard to explain, especially if you didn't learn it in the course, like because you didn't. It was there until later, but that was just the one thing I wrote extra that was really nice. But other than that, I mean, I think that's it, Kinran. I think you took all the points out of the presentation, and I think you did a great job. So congratulations again.
Thank you very much. Sorry for the unstable internet
Oh
connection.
yeah, don't worry. These things happen. So as we saw that it did its thing in the beginning, for the people that are watching the video, that's the first like 5 minutes. That was what's going on. So just maybe, well, we'll try and edit it or not. If not, you just skip forward. But for everyone else that's watching, you can do this here. What Kinran did with his project, you can apply this to your own learning. And if you want to take a course with us, you can also do this in order to get our official certificates. So that's one thing to consider for everyone that's watching. And yeah, that's it from us. Again, thank you, Kinran, very, very much. And for us here at The Construct, we want to say bye-bye, and we'll see you next time for our next presentation. All right,
Thank
bye-bye,
you.
Kinran.
Bye.
All right, guys, bye. All right, cool. We're done.